Hi everyone, I did my community project on the chemistry behind oil spills. So what are oil spills? It's a release of petroleum hydrocarbon into the environment. It occurs by accidents including machines and human mistakes. The cost for cleanup is $2 to $10 billion, and the damage is it can kill an environment, harm animals, and harm vegetation. Cleaning oil spills. So we have land booms, hydrocarbon pads, enviro-solution sweeps, and bioremediation. Land booms absorb oil and can prevent further spread of oil. Hydrocarbon pads are best for pools of oil. So if it's like in a ditch, you can place one and it'll absorb the oil. Then an enviro-solution sweep is a sawdust-like material that contains microbes that consume the oil, and bioremediation consists of decomposers and enzymes. And this is what I'll be focusing on. So bioremediation is very cost effective, however, it's time consuming and can take multiple decades. It consists of bioaugmentation and biostimulation. Bioaugmentation is the disbursement of exogenous microorganisms into the contaminated area, and biostimulation takes existing microorganisms and enhances them with the bioaugmentation. Scientists are trying to advance the time that it takes for bioremediation to run its course, and they're doing this by testing detergents such as humic and fulvic acid solutions and polycomplexones. So polycomplexones come from aminodiacetate derivatives of fats, and polysaccharides, which are sugars, from base hydrolysates of protein-containing waste. Aminodiacetate is a white solid and it contains a dicarboxylic acid amine, and then it has polysaccharides, like I said, sugar molecules or glucose molecules. Hydrolysates is a hydrolysis product, and it's a very environmentally friendly soil detergent. So here we have the amino acid structure with a carboxyl group and the side chain R, and that's just the general formula, and then we have an R group example. So here we have humic acids, and it creates a very healthy soil environment. Soils with high humic acid amount have good structure. It's a light, fluffy, it's good for root penetration. It contains a lot of oxygen, and there's reduced erosion. And there's increased microbial activity, water retention, and transferring of nutrients. Humic acids are dark in color. They're not soluble in acidic water conditions, but they're soluble in alkaline water conditions. They protect plants from toxic metals, and they help with plant and soil exchanges. So here we have fulvic acid, which is the next detergent, and it comes from the organic acid family, and it's made of natural compounds and humus. It's formed by the breakdown of plants and animals. Fulvic acids are very similar to humic acids, and some people even take fulvic acids to detoxify their body, and it does the same thing with soil. It detoxifies the soil. So here is what a fulvic acid molecule looks like. And then I have the chemical formula of the fulvic acid at the bottom of the slide. So what's the difference between humic versus fulvic? So humic acids are large molecules. That is the top picture. They work best for natural growth in an environment. And then we have fulvic acids, which are smaller molecules, which is the second molecule listed in the picture. And they're used for fuller application, and this is fertilizer straight to leaves or soil. And the main activity is transferring nutrients through the cell membrane in plants. So here we have humic substances, and you can see we have the fulvic acids and humic acids in the picture to the left. And then we have on the right a diagram of humic substances and parent material, which is the soil, and how these detergents react in the soil. So detergents emulsify the oil and sludge, and detergents seep through the soil after emulsification. So that's kind of just mixed up soil that's it's not compact. And detergents are introduced with soil carriers such as peat, sapropyl, and sand, and they're made up of humic, fulvic, or polycomplexone solutions. And on the picture to the right, we have the contaminant, which is the food, so that would be the soil, and we have the enzymes and other nutrients working to decompose this, and then we have the microorganisms. So the enzymes would be the detergents. So how have scientists used humic and fulvic acids and polycomplexone solutions as detergent bases in oil cleanup? So they have tested both humic and fulvic acids, and they combine these with copper and zinc, and increase the bacteria activity in the bioremediation. They've tested polycomplexone solutions. It was an aqueous solution of sodium salts, copper nitrate, zinc nitrate, and acidic peat, which is the oil carrier. And then they added it to a sample of oil. Within the 15 minutes that they did, the smell of oil had completely vanished. A sample of sludge, they took a sample of sludge and added 10% of the solution, but this time they put amino acids along with it. And there was a slight heating that was observed, and thermophilic bacteria that lived in the peat adapted to the sludge, so it made for a better environment for that bacteria. And in conclusion, both solutions accelerate decomposition of oil. However, polycomplexone solution, including the amino acid, makes a more friendly environment for the bacteria. So therefore, this is a better solution as a detergent. So we have the prevention of oil spills, tighten bolts, check oil lines, make sure equipment is up to date, build berms and trench in case of leak, make sure there are no cracks in hydraulic lines, take time and be cautious with oil transportation. You can spread awareness, but a lot of these preventions should be focused in the oil industry. So what does this mean for communities? So we have worldwide community. It's big for the issue of global warming and pollution. If scientists can dial this in, the process can be largely shortened, and the content of oil is almost zero in oil spills. And oil pollution can easily be resolved, so therefore researchers can focus on the prevention of oil spills since they already have a solution. And reducing pollution will reduce global warming. So for my community, I'm part of the Nordic ski community, and we butt heads with global warming because we need snow. My community has multiple organizations that we're trying to protect the earth from global warming. And we have POW, which is protect our winters. Snow is slowly disappearing where it is known to heavily accumulate, and this is evident in glaciers due to rapid rates of melting. And then we have prevention of global warming. So stopping pollution and global warming is a must. And we need to be more cautious with pollution, and people can take steps such as recycling, being aware of their water usage, and transportation that does not involve emission of carbon dioxide. So this can be biking, walking, running, or carpooling to reduce the emission of CO2. And passive ways of reducing pollution is voting for politicians who value the environment and value the reduction of pollutants in the environment. So here are my citations, and I'd just like to thank you for your time to listen to my presentation.